right? So let's say now we have an object placed 30 centimeters away from a convex lens. A convex lens. What kind of lens is that?
Um,
Divergent,
convex.
diversion or conversion?
That is a convergent.
Correct. And how does it look like? This, oh gosh. Does it look like this or does it look like this? One or two?
One.
Yes. And that means the incoming light rays is what? What would happen to the incoming light rays?
It'll be coming closer together.
Right, they're gonna converge. They're gonna converge that point. Wherever they converge, we call this the what?
That is the focal point.
Yep, focus points. All right, awesome. So we have the object distance, and what do we use to represent the object's distance?
The object distance
Like, what is the symbol for that? Is it
is
F? Is it U? Is it V? Let me know.
again U.
Yep. So the object distance, object distance, that is U, is equal to,
U is equal to TCN.
and did they give us the image distance?
Now
Nah, so we don't know what that is. And what we use to represent the image distance?
A.
Right. We don't know what that is. All right, and a question mark there. Did they give us the focal length?
Yeah, 15.
Right. And what's the movie used to represent the focal length?
F.
Capital F, common F.
Common F.
Correct. Right. So we have U trying to find for V, and we have F. What formula to use?
Um, 1 over, 1 over F. Formula.
1 over F is equal to,
1 over U plus 1 over U.
right. So tell me what to plug in.
We need 15 by F and 50 by U.
So we're gonna put 1 over
1 over
50
and 1 over U.
equals to
Um, equal to 1 over 50 plus 1 over U.
plus 1 over, right. So what's the next step?
From the you're rearranging the equation to make 1 over V the subject.
Correct. So how are we doing that?
So you're subtracting 1 over 50 from both sides.
Perfect. So then I could say 1 over V, that'll be equal to 1 over 15 minus 1 over 30. That makes sense.
Yeah.
Right? And I want you to tell me what is 1 over 15 minus 1 over 30. Plug into your calculator.
Alright.
And I want you to tell me the answer as a fraction.
And that's it's the answer 1 over 50. My calculator. I using the ABC one.
What the answer is an improper fraction. If it's an improper fraction, or whatever the case is, tell me it is an improper fraction. Wait, you get 1 over 30?
Yeah.
Okay, that's correct. 1 over 30. So let me show you a trick, right? Anytime you have one fraction on either side, you're allowed to flip. So if I flip 1 over V, what would that become?
V.
That become V, right? And if I flip 1 over 30, what would that become?
30.
Correct. So that means that my image distance is,
30.
but that's interesting. That's very interesting, right?
Object and the image is the same. So,
Correct. And if they're the same distance apart, do you think that they are magnified?
no.
For example,
If they're magnified,
yeah, you think the image is being magnified?
nah.
Nah, it's the same size because the distances would be the same. So it's basically like a mirror, you know. It's basically like a mirror. Because when you look at yourself in the mirror, any distance from you on the mirror, this be the same of your image in the mirror. You understand what I mean?
Yeah.
Yeah. Right. So the magnification, the magnification is just one, right? This magnification is one. Formula for magnification is image distance over object distance. What was my image distance?
30.
Right. And 30 over 30 is
1.
perfect. And that don't have units because this would be in centimeters, this would be in centimeters, so it would cancel off. So you don't have any units, right?
Yeah.
Now let me do a sketch of this thing here. You feel I have enough space for 30 centimeters?
Nah, you got make it serious one.
Yep. So let me you want to make I feel like 5 is a good scale. If I use in 5, that 30 centimeters will turn to what?
centimeters will turn to 6.
It's in the 6, this goes into 6, and this 15 will turn to what? That will turn to 3. So let me do a sketch of the graph. This line I'm drawing here, what we just call that? So P.
Um, is not sure.
Principal
Point of or principle of axis.
principal axis, right? Principal of axis. Yeah, principal axis. And I'm gonna draw my convex lens. And whenever I have enough space here, I'm gonna draw a big right. You remember the two rules? Let me know if you remember the two rules when you're working with lenses.
Um, nah, I don't
Okay. Well, I will show you back again. So my object is, well, 6 centimeters in this case. I will have to shift this in here. Let me shift this, right? So my object is over here. These are red. These red. Yes, so my object is over here. Where is my focal point?
It could be 3 centimeters away from
Right? Cool. And that would mean my focal length on the other side of the lens is also
2.
right. So let me remind you how these rules work. So let me just draw my object. So that red line there, that red dot, that's my object.
Yeah.
And how what the height of the object to be? What height?
Right.
How
Let me
much?
say 1.5.
1.5?
Yeah.
Okay. No, I gotta make this lens bigger. But do that.
Yeah, good day, sir. Sorry for joining late.
I was surprised because I know normally you'd be on time and thing. I was
Yeah, nah, I was busy today and I forget.
oh shucks. Well, it's good to have you, right? So I just draw a line, but all you understand is that convex lens is supposed to be, right? So, um, Justin, I want you to tell Nicholas the two rules when you're dealing with a convex lens. What are the two rules? Tell me the two rules.
Two rules for convex lens. A ray of light which is parallel to the principal axis after refraction appears to be coming from the focus. And rule two, a ray of light passing through the optical center passes straight through without being refracted.
Right. So Nicholas, this is a convex lens. So after it passes through the lens, it will converge to my focus point. You understand?
Yeah, I understand.
That's the first rule there. And the other one, if you have a light ray and it passing straight through the optical center, is go straight through, right? So can you show me where my image would be situated? Can you show me? If you
On
go
the
to,
tip,
yeah,
I, um, it would be like at the
yeah,
point where, like you said,
that's actually very accurate. If you're right there. And let me look at that. Let me observe this. So Nicholas, you said that this was 1.5 centimeters, sense.
yeah,
Let me see. Let me check this out. What are looking like?
about 1.5.
Correct. So, and if we measure the distances from the optical center, it should be the same, right? This should be 6. And how much this should be?
Would be 6.
Bam. Look at that. And since my image is in front of my lens, is it real or is it virtual?
Is real.
It's real, right? Because it's in front of my lens. Cool. So you understand that perfectly, right?
Yeah.
Justin, tell me what kind of lenses gives you virtual images? Where's the only lens has give you a virtual image?
The only lens that is giving a virtual image is concave lenses.
Yep. Because what has happened is the light ray it was spread out, and so it will appear to be coming from the focus point, like you said. And so you have a point of intersection behind the lens. And if it's behind the lens, is a virtual. Nicholas, you understand what I mean by virtual? Behind the lens?
Yeah.
Right, say no more. And if it's virtual, when you're plugging it into here, it'll be negative. Yeah. Let's see if I can find a question on that. Hmm. Give me a second, guys. So Justin, what is he good? Was he good these days?
Dave was relaxing today, so I was kind of busy.
Oh, how are the Indian arrival? They going?
Yeah,
They going good?
yeah.
Are they arrived straight from India? I
What's up?
say all they arrived straight from India. They arrived straight from there. Um, Carlos, did you do anything for Indian arrival day?
Well, this morning I went to work with my mother, so that I come like 2 o'clock. That's it.
What? You went to work?
Yeah.
Okay, okay. Big up yourself. Big up yourself. Final nice question. Right. Are they want a question book? I mean, if I have a question booklet, I have like a bunch of questions, like fractional questions.
Like past papers.
No, not past papers. Is like past papers inspired past paper inspired questions. I have all the past papers. I could send all the past papers if I want. But I have up to 2024. This like 2024 January and June. But this book I have here have questions inspired from that. So I will send it. I think I could benefit from it.
Right?
It's 106 pages, so it take a little while. So what I want to to do is I want to open up that document and go to the what page to go to. I want you guys to go to page 63. Go to page 63. Yeah.
So you could see what guy you kind of break up.
One page 63. 63. All right. So guys, who wanna help me with this question? Who wanna be the brave soul? Let me hear. Who wanna be the brave soul? Hmm. Justin, Nicholas. Which one on there? Think I can handle this. Let me hear. Both are listening real quiet. I don't know. How are they saying so quiet, boy? Wait.
I can do it. I can do it.
All right, all right. Say no more. Say no more. I like to hear that. Three questions from there.
Our object of height 2.5 cm is placed 12 cm in front of a convergent lens. An image is produced 4 cm behind the lens. Using the lens formula, calculate A, the focal length of the lens, and B, the magnification of the lens.
Right. So they gave us the object height. They told us that it was placed 12 centimeters in front of a convergent lens. And they say an image is produced 4 centimeters behind the lens. It's a very, very interesting question. 4 centimeters behind the lens. You like that typo there? Because if they're saying it's a convergent lenses, it do have the image is always produced in front of the lens. Always. So something wrong with this question. Yeah. Only for divergent lenses do you have the image being formed behind, right? Justin, you could just check all the cases from up. In all of the cases he did, or we did the image ever form behind the lens?
Uh, no.
Yeah, so that question has something wrong with it. If you have a convergent lens, no way could they have an image form behind the lens. That just don't make sense, right? Might have to come up with a question. Hmm. An object is placed 5 centimeters behind a divergent lens with a focal length Justin, give me a focal length. Give me a focal length. Shoot.
5 centimeters.
Nah. I mean, technically, you can do that, you know. Yeah, yeah, we can do that. Yes, we will see what will happen. Right? Of 5 centimeters, okay. So an object is placed 5 centimeters behind a divergent lens with a focal length of 5 centimeters. Calculate the image distance. Now, first things first, right? Justin and Nicholas, anytime you have a divergent lens, first of all, a divergent lens is also called a what? What is a divergent lens also called?
Concave.
Yep, also called concave. And concave lenses always produce what? What do concave lenses always produce? Justin, you had to know this one. What do concave lenses always produce?
I remember I gave my note here, but I don't know if that is the answer you're looking for.
This is what I'm talking about. Let me show you. So no matter where you put the object for a concave lens, it will always get a virtual image. The image will always be upright and it will always be smaller.
Daddy knows I was going to read, yeah, but I didn't know if it was correct.
Yeah, well, that was correct. So if we have a concave lens, then I know for sure that my image is going to be what? My image have to be what?
Virtual.
Had to be virtual. And it had to be bigger or smaller.
And to be smaller than the object.
Correct. Now here this, guys. This is catch. If you have a divergent lens, V is now negative. That's the only catch there. Right? That is the only catch. So, Nicholas, let me do this question together. So did they give us the object? Did they give us the object distance?
They give us not a focal or weight yet.
They
5
did
centimeters.
5 centimeters. What is the focal length?
Focal length is 5 centimeters.
And the what is the image distance?
And then we don't have the images.
So Justin, we working with U, F, and V. A formula, you know, have all of them three things in it.
So, 1F equals to 1 over V plus 1 over, no, 1F equals to 1 over U plus 1 over V.
Right. Now here is what can I since we're dealing with a divergent lens, right? And it's virtual. This is the catch. V has to be negative. It has to be negative. So you all will see what I'm going to do. Instead of writing 1 over V, I'm going to write 1 over minus V. Now, 1 over minus V is the same thing as what? Let me ask you this. If I have 1 over minus 5, what is that number equal to? Tell me, Justin. See if you can figure it out. 1 over minus 5. I could just write out as what?
Minus 5 over 1 will be minus 5.
Now that is 1 over minus 5. So that would be minus 1 over 5. Let me explain that. So you have a positive here divided by a negative. What is a positive divided by a negative? Tell me. From maths, what is a positive divided by a negative?
A negative.
A negative. So that's how we end up with negative 1/5. So you all will see what I'm going to do. So we have 1 over f is equal to 1 over u. And instead of writing plus 1 over minus v, Nicholas, I think you know what I'm going to write? See if we can figure out what.
Thinking you're gonna write 1 over, minus 1 over v.
Yes. Because this whole thing here, that would turn into a negative. And Justin, why it turn into a negative for? Why it turn into a negative? Why that whole thing turn into a negative?
Because it's a positive divided by negative.
Correct. And if you have a positive multiplied by a negative, now is a positive multiplied by a negative?
Positive.
Nah, positive by a negative is a negative. That's why I end up with negative 1 over v. Yeah. I feel like you're a little confused there. Let me show you something. If I had 1 plus minus 7, that's the same thing as 1 what? Come on. Where's that plus by minus?
Plus by minus minus
Right, so we're gonna put 1 minus what?
7.
Correct. So over here, I have plus 1 over minus v. Now 1 over minus v, that will become minus 1 over v. And then we have a plus by a minus, so I just write minus 1 over v. You understand? Let me know if you understand how it confusing you a bit.
No, I understand.
Okay. So now we could actually plug in everything. So, Justin, what was my focal length?
5 centimeters.
Right? What was my object distance?
5 centimeters.
And do I know what my image distance is?
No.
Nah. So how would I find are you gonna run into something weird then? You would end up with well, 1 over 5 minus 1 over 5 is 0. That's weird. Huh. Let me plot this graph and see what's going on. Because this is very, very weird. It's very weird. Let me just do a quick example. Because it's supposed to be smaller, it can't be 0. Yeah, that's very weird. Five here. Oh no, I wouldn't be able to do that, Justin. Justin, I'm gonna show you something. Justin, you see in this?
Yeah.
So if you put your if you were to put your object exactly by f, then it wouldn't work. It wouldn't work. Let me see if I could show you why that wouldn't work. Let me start off with something like this. I'm gonna start off with something and then we'll work our way closer towards the focal point. But yeah, I don't understand why it's not working. Let me just say over here was the focal points. Over here was the focal points. And I place my objects over here. Right? So I have my objects. What's the first rule I'm going to use? I'm dealing with a convex lens. Sorry, a concave. I'm dealing with a concave. That's the one that's diverged. So it's my first rule. Dealing with a concave.
A ray of light which is parallel to the principal axis after refraction appears to be coming from the focus point.
Correct. So this is what I would do. You understand?
Yeah.
Right? And then the next rule.
A ray of light passing through the optical center passes straight through without being refracted.
Right. So where's the can you show me where the image is? I think you had told me that you're not able to annotate.
Nah, I think I'll get you with it now.
Okay, well, see if you can show me where the image will be formed.
The image will be somewhere here.
No. The
Um,
image is wherever you have a point of intersection.
ah,
Always.
the only point of intersection is here. Alrighty.
Correct. And what kind of lens this was again? Is a convex or a concave?
Concave.
Concave, and concave lenses, the image is always what? What is the image always?
The image is always
It's always,
smaller than the object.
right? That's correct. It's our V. The image is always,
Virtual.
and if it's virtual, then the image is forming where? In front of the lens, behind the lens.
Um, Behind the lens.
Right. And again, the image is wherever I have a point of intersection. Nicholas, you understand, all right?
Yeah, I understand.
So let me try to bring the object closer now and see what happens. Let me just say I bring it here. Let me see what's gonna happen. So, Nicholas, I want your help for this one. So I'm gonna draw my line. The first rule is that a ray of light parallel to my principal axis will appear as if it's coming from the focal point behind the lens. So, Nicholas, look how we're going on, right? So, hence we know that's it's a concave lens, right? So the light ray would spread apart. It would diverge, right? You know that.
Yeah,
So it would diverge like this, but you can't just draw that. You have to make sure it lines up with the focal length or the focal point behind the lens, like so, right? I don't know if you understand what I'm talking about,
yeah, I understand.
right? So can you show me where the image is?
It would be okay,
Over here?
yeah,
Notice it's still formed behind the lens, right? It's still behind the lens.
yeah,
Now here, what? Let me bring it even closer, like real close. And let me see if we can notice a trend, right? Let me see if anything will happen. So that's the first rule. I'm gonna apply the second rule. Okay, I mean it still look like it still looks like it have an image. And let me try to do it directly on the focal point and see what happens. Let me see what happens there. right? And Nicholas, you could tell me if anything, if you observe anything going on, right? So no. But that's supposed to work then. That's supposed to work. No, why it's not working here? That's very weird. Um, okay, I will leave out this question. I mean, NTC that image is still being formed though.
Yeah.
Yeah, so that's kind of weird. Calculation kind of weird.
Hold on. If you move the 1/5 in the last part of the equation we're doing there, then that'll be 1/5 minus 1/5 is equal to negative 1/v.
But that'll be zero.
Yeah.
And that would mean that,
But
let me show you why that is pressure there. Let me show you why that's pressure. Show you why that wouldn't work out. If you have 0 is equal to minus 1/v, and you multiply both sides by -1, you're going to put 0 is equal to 1/v. And now if you try to flip that, you're going to put 1/0 and can't divide by 0. So that wouldn't work out. That can't work out mathematically.
it's remain as 0.
Yeah. Oh, so that's really weird. Yeah. So I'll put asterisk by this and come back to it. Trouble going on here. Unless I come up with it's an invalid question. Could be. Right, but that's basically it for lenses. You don't really have to know much more. You had to know how to sketch a diagram for a convergent lens, a convex lens. You need to know how to find for the magnification, the focal length, the image distance, the object distance, that kind of thing. And all the formulas you need to know. These are all of the formulas you need to know. So if you don't have it, copy it on one time. Right, Nicholas, you have these formulas?
And a copy on the magnification.
All right. Justin, do you have these formulas?
Yeah, I have it from last class.
Nice. Oh wait, I make a small mistake. I'll get back to that question and just clear up the confusion. I make a very small mistake, right? You have this copy down, Nicholas.
Yeah.
All right. So it's not this that's supposed to be negative, you know. It's not this that's supposed to be negative. Let me show you what's supposed to be negative. Like when you're running calculations, you don't put that as negative. You put the focal length as negative. So that would fix the problem over here. So Nicholas, you see over here how you'd get 0?
Yeah.
If I had minus 1 over 5 here, I would end up with minus 1 over 5 minus 1 over 5, which would not be 0. You understand?
It'd be minus 1/10.
Wouldn't be minus 1 over 10. I
Or
mean, 2 over 5. Plug it in the calculator. Minus 1 over 5 minus 1 over 5 is minus 2 over 5.
yeah.
Yeah. Justin, sorry for that confusion there. Right, so let me just fix up that. Right, so Justin, I want to just clear up any confusion you have, right? I just want to do that. So I want you to stay unmuted. I'm gonna be here now.
Yeah, I hear
Okay.
you.
So we're dealing with a divergent lens, and divergent lenses, the image is always formed where? Where is the image always formed?
Behind the image.
In behind the lens,
Yeah, behind the lens.
right? Because it's virtual. So if we're dealing with a divergent lens, it's supposed to be 1 over negative f. So it's supposed to be minus 1 over f. So what the note's supposed to say is that for divergent lenses, the focal length is negative. That's what the note's supposed to say. Right? So you would have negative 1 over f is equal to 1 over u plus 1 over v. Right? So Justin, let me plug in everything now. So on the left-hand side, that'll be minus 1 over what? What was the focal length?
Focal length was 5 centimeters.
Right? What was the object's distance?
5 centimeters.
Right? And do we know what the image distance is?
No.
No, we don't. So I want to find for one, I'm trying to find for v, right? So do you know how I would find for v?
Not really.
Not really.
No.
So basic maths. If you're trying to find for something, you're gonna move everything across that don't have the unknown in it. So in this equation, what is the unknown? What do I not know for?
The V.
I'm trying to find for v, right? So
Yeah.
does the 1 over 5 have v in it? You see
No.
the v in this?
No.
So everything that don't have v in it, you move it across. So here what I'm gonna do, I'm gonna take the 1 over 5 and I'm going to move it across. Now, if you move across something, what happens to the sign?
It changes to negative.
Correct. So tell me what to write on the left-hand side.
Minus 1 over 5. Minus 1 over 5 equals 1 over V.
Perfect. Now, what is minus 1 over 5 minus 1 over 5?
That's
Let me show you a trick, right? Let me show you a trick. Justin, what is 2 plus 5? 2 plus 5?
7.
7. What is minus 2 minus 5? You see, you're taking a little long to answer that.
Yeah, minus 7.
Minus 7. I'm going to show you how to work that, right? So, anytime you have two negatives, I'm talking about when you're minusing it. I'm not talking about when you're multiplying or dividing. Anytime you have two negatives and you're minusing, you add it like if it was normal and just put back the negative sign. Simple. Where's where's 9 plus 2? 9 plus 2 is what?
11.
Where's minus 9 minus 2?
11. Oh, minus 11.
Right. The marks in this question. Where's 1 over 5 plus 1 over 5?
Um,
Simple way to answer that. How much 1/5 is in? How much 1/5 is in?
2.
Right, so that's 2/5. And if you have negative 1 over 5 minus 1 over 5, that's just negative 2 over 5. You understand?
Yeah, catch on, catch on.
Nicholas, you catch that?
Yeah,
You could just say 1 over 10, but do that. Do that.
yeah, I'm a mistake.
So 1 over 5 plus 1 over 5, we have 2 1/5. So I can just write as 2 over 5. And since it's negative and negative, we just slap on back the negative sign. I mean, if I have a Casio, that easy thing, but I think I should know how to do the proper thing anyways. Right? Cool. So, this last step, you can cross multiply, but there's an easier way to do it. I'm going to show you all that easier way. Right? So, Nicholas, anytime I have a single fraction on either side, what am I allowed to do? What am I allowed to do? A single fraction.
But on the two sides,
Reason?
a single fraction on the two sides.
Yeah, I could do what? Take inspiration from your previous question. I had 1 over
Then
v.
could flip it.
I could flip it. So we're going up with if I flip this, what would that be, Justin? If I flip minus 2 over 5, what would that become?
You flip it,
Yeah, if I flip minus 2 over 5,
minus 5 over 2,
right? Minus 5 over 2. And if I flip 1 over v, what would that become?
v over 1,
V over 1, which is just
v.
v. So then v is equal to what then?
v is minus 5 over 2,
Right? And what is minus 5 over 2 in the calculator?
minus 2.5.
Yep. Now, since it's a virtual image, that's why you're gonna get a negative value there. That is why you're gonna get a negative value. Because your image is not forming in front of the lens, no. It's forming behind the lens. So that's why you're getting negative. And let me see if that makes sense. Let me actually do the diagram for that. So Justin, I want you to help me with this. Right? Hmm. So Nicholas, if I asked you if it was a magnification, would you tell me it was a magnification?
Um, Magnification of
For it to be a magnification, yeah, you have two ways you could figure it out. The image height is more than the object height, or the image distance is more than your object distance. Is our image distance more than the object distance?
image distance is more on the other distance.
You sure about that? My object distance is 5 centimeters or no?
Oh, no. The object distance is more on the image.
Right, and that's an easy way to figure out if it's a smaller or a bigger. Easiest way. Let's fix up this diagram here. When I saw it earlier, um, Nicholas, you was talked earlier.
Uh,
You know earlier?
now me and she personally,
Or just know about you? I feel like you know plenty people.
I know plenty people, just not she.
Oh, but Nicholas, how Kiara going?
yesterday I wake she up for maths and
Then I'm asked that
I
yesterday. She probably get
yeah,
back
but
to you.
she
Can you
passed
imagine?
me off. She got with my hurricane. She have
I can
um
imagine Kira, you know. Nicholas, why you? Oh Lord, I can imagine. You know, up to now, I still didn't get the hard to work. I didn't get out up to no. Yeah, she really tell me she's gonna do that, you know, but I ain't get nothing. I ain't get nothing at all. Ah,
delinquent again.
yeah, boy. Justin, you think I gonna get a homework?
Now, if she has enough to know, well, I doubt you get that.
I doubt I get that as well. Hmm. Shall I be studious like all you? Even though they come out late and thing today. Cough, cough. Yeah.
See, I had dedicated to physics. No matter I join late, I still come to class.
Yeah. I'm happy that I still come to class. If it had reached five, if I had reached 5:30 or like 5:40, I would have end class. But I hope I'm not giving all the ideas. Come to class. Yeah. Right. So let me actually plot this diagram. So Justin, in this question, the object distance and what was the same? In this question here, what was the same?
The object distance and the focal length was the same.
So they're on the same point, right?
Yeah,
Because both of them 5 centimeters away from the what? Start with O.
the optical center.
Yes. I'm gonna apply my first rule. My first rule is that um if I have a light ray that is, Thelma,
We have a
Thelma.
light ray that is parallel to the principal axis.
Yeah, that's the first rule there. Yeah,
After refraction appears to be coming from the focus point.
correct. Now, this is my focus point, right? This thing over here. And
Yeah,
it is 5 centimeters away from my optical center. Now, to figure out how it's going to diverge, this is what we'll have to do. I will have to take a ruler and I would have to align this with what? What am I aligning this point with? Could I just draw it like this?
no, I'd have to pass through the optical center without refracting.
No, you're talking about the other rule. You're talking about
Well,
what rule you talking about? You're talking about this rule, right? Um,
yeah, that one.
that one. But we're not talking about us yet. We're saying if you have a light ray and it's parallel to your principal axis, it appears to be coming from your what?
Focus.
Your focus. So could I just draw my line like that? Is this passing through? Is this looking like it coming from a focus point? Is it?
No,
No, it had to come from the focus point. So you think this correct? Is that coming from the focus point?
no,
No, I had to align my ruler. So where I had to put my ruler? Where I had to align up with
the focus point.
focus points. Is this correct?
Nah,
Nah, I was trying to see if I could catch you lacking.
you
But
almost catch me.
ah, it seems so. It seems so. And that's a bit off. A bit off. Kind of tough to get this right. So um, let me know if that looking correct.
Yeah.
Yeah, that looking about right. Honestly, and that's my first rule. What is my second rule?
The light ray that passes through the optical center passes straight through without being refracted.
Where's my optical center? Where is it?
Um, right.
Yep. So I'm gonna draw light ray from. I remember last class he was making that mistake. Sometimes instead of drawing it coming from the top, it was drawing it like over here and thing. Remember?
Yeah.
And I'm telling you, nah. Both light rays are to be coming from the same point and as on top of the object. Right? So tell me, where are you seeing a point of intersection? You see a point of intersection in front of the lens?
No, behind the lens.
Behind the lens, and we expecting that. Where is
Yeah.
the point of intersection?
Body.
Nicholas, you agree with that?
Yeah.
Yep. And could somebody tell me some properties of this image?
The image is upright. It is smaller than the object.
Right.
And it's a virtual image.
Perfect. Now let me measure some stuff here. Let me measure some stuff. So I'm going to measure my object distance. What do you think my object distance is? Do we know what that is? Was it given to us at the start of the question?
No.
It was. The object distance is 5 because it
Oh,
said
sure.
object is placed 5 centimeters behind it. So this is 5 centimeters right here. And according to my calculations, right, V is supposed to be, well, negative 2.5. Well, that's basically 2.5. Right? In negative is just to show is a virtual, right? So this over here, when I measure this, it's supposed to be what length?
2.5.
Supposed to. Just anything in physics, go physics.
Uh, yeah.
Let me see, it looking like half a 5.
Yeah.
Let me measure it. Well, look at that. Physics.
Exact.
Now we're talking about looking like 2.5.
Yeah. Around it.
Around it, that is 2.5. What you saying? Much? Yeah. Well, actually, it's a bit off, eh? But
Yeah, that go
we'll,
work. That go.
we'll call it 2.5. So everybody
Yeah.
okay? Everybody all right? I see it
Yeah.
working.
Yeah.
Nice. And let me just explain something, guys. So I just write a little note to the side one time. Note. I want to copy this down. If the object distance, if the object distance is more than image distance, it means that image let me hear. Nicholas, if the object distance is more than the image distance, it means that the image is smaller or bigger. What do you think?
Smaller.
Justin, do you agree? If the object distance is more than the image distance, do you think the image is smaller or bigger?
Smaller.
I mean, you see it here, right? What was bigger? Was it U or was it V?
U.
U, and U represents the object distance, right? And I mean, you can have see it for yourself. Which one bigger? Object or the image?
Object.
Object, right? And is how much times bigger? Just by looking at it.
2.5 centimeters bigger.
Now, I wouldn't say 2.5 centimeters bigger. We're talking about the height. So, like, let me just say the height of this was 4. What do you think the height of this would be?
Now 2.
It will be 2, right? So if the object distance is more than the image distance, it means that the image is smaller than the object. So Justin, anything confusing you at all? Yeah, let me know now. Thing.
Nah.
All right. So if I give all that a question, all I could do and we can move on, right?
Yeah.
Nice. And in case I was wondering, this is where the formulas for magnification come from. So that is why, um, let me just run the formulas one time. So the formulas for magnification. Could anybody remind me the formulas for magnification?
Magnification is equal to object distance over image distance.
Nah, magnification is the image distance over the object distance
Oh,
because they compare any image to the object. That's one. And what's the other formula for magnification? Let me give you an example. If the height of this object is 4 and the height of this is 2, what is the magnification? How much times bigger or smaller did I make the image? Let me hear. Justin, how much times if the object have a height of 4 and the image have a height of 2, how much smaller or bigger did I make the image?
2 times smaller.
Make it 2 times smaller. And 2 times smaller is the same thing as a half it, right? If my image was, let me just say my image was 8 and my object was 4, what was the magnification there? How much times bigger I make the object? Sorry, how much times bigger I make the image? If my image is 8 and my object is 4,
2 times bigger.
make it 2 times bigger, right? So you're always comparing the image to the object. So the first formula is image distance over object distance. And what's the other thing I could compare? So I could compare the distance from the center. I could also compare what? What is this? This over here. You see what are the objects? How each?
Object height.
Yes, I can compare the image height, the object heights. Yeah, so I could copy down all that.
Yeah, I finished copying them.
All right, nice. Anybody else still copying it down? Nicholas, you still copying down?
Finish.
All right, nice. Okay, we'll try the question from this year or 2024.
Yeah.
Okay. All right. You know more. This is January. Felix. Let me get June. One second. Did I send the 2024 paper on this chat? On the class chat?
2024 paper.
Yeah.
May 2024, I sent it.
Okay, nice.
I paper 2.
Yeah, I just downloaded it back on my iPad. But I want you also open that and go to page. Let's see. Hey, but the real test lenses this year.
Yeah,
Wow,
the first question is a lens question.
the real bring lenses. They even think twice about bringing lenses. Wow. So best we do all the lens questions and that and move on. The next thing I'm gonna move on to, I just wanna do sonar waves. Didn't you do that in school? Like like a boat measuring the distance, like the depth of water using sonar waves. Will you ever do that?
Yeah.
Or just echoes? I wanna do that. And then I want to move on to reflections and refractions. Right? And that'll be it for waves and optics. Um, Justin, how physics going in school? Rocky school and thing, or he's still staying home?
Now, well, last week didn't come out at 1 or 2 days, and we didn't really do much. So,
Um, but things kind of all over the place.
yeah, that whole week we ain't really get much work. Most of them teaching them stay home with that real field trip and things. So,
Oh, so are they didn't do sound, are they didn't do sonar waves and echoes and things yet in physics?
nah.
Yikes. Don't worry, you'll cover it here. So I mean this first question, or they should eat it up, is food. Like nothing, like Chinese food. Yeah. Like tell me fast, where's Lindsay? What is Lindsay?
Lens, concave,
Lindsay is a concave, also known as a concave lens is also known as a
Divergent.
right. So any light rays that come and hit it, what happens to them?
Like a divergence spread apart from each other.
Right. The only one that will go right through is if it passes through the optical center. Pass right through. But the others will diverge further apart. Okay. Lens B. Lens B is a what kind of lens?
Convex.
convex,
Yes. And we also call that what kind of lens?
convergent.
If all they wanted to flex in the exam, or they could have just do this. Even though they didn't ask. But they could have flex like that because they're bad like that, you know? Yeah. Conversion, right? Let me check out the rest of the questions. Prepare for a graph question, right? So who wants to read this question? Anybody? You're looking real scary, yeah? Ooh. Let me get who wants to read the question. Justin, I feel like you're real quiet, you know. I feel like you should read it.
Yeah, I don't mind.
All right. Get the question, I read.
A student uses the apparatus shown in figure 2 to determine the focal length of the lenses. She adjusted the position of the lens and screen to obtain a sharp image on the screen. She measured the image distance V, deduced the magnification M of the object, and recorded her results in table 1 below.
All right, before we even continue, let me understand what's going on, right? We could draw this diagram any way we understand it, right? So let's do that real quick. So my object is over here, right? That is my object. So I just draw my object like so. And this over here, what kind of lens is this? Tell me, what kind of lens is that? What kind of lens is that? Convergent, divergent. What lens are looking like?
Convergent.
Looking like a convergent lens. So then you have a convergent lens here, right? And then this over here is your, what does V stand for again? V is here,
Image distance.
right? And well, any question? What was she changing? What was she adjusting? What was she adjusting?
She adjusted the position of the lens.
Now, if she changing what the lens is, and that would mean, well, and that would mean U and V changing. Think about it. Let me
Yeah,
know if that makes sense because um Justin, if she change the lens from here to here, then now my object distance will change and then my image distance will change, you understand?
yeah,
So them two things changing, so it's not fixed. But this is essentially the diagram you have. And one more thing. Since this over here, since that is a convergent a convergent lens, that means all my images would be produced where? Where would it be produced? Behind my lens, in front of my lens, somebody tell me.
in front of the lens.
In front of the lens, so it's real, right? And
Yeah,
all my images would be what?
inverted.
Would be inverted, right? Cool, cool. I'll ever try to make a projector out of a magnifying glass. I'll ever try that?
No,
No? Let's try it. Um, it's real cool. Basically, you just get a shoebox, right? You put your phone inside the shoebox. You cut a little hole, put a magnifying glass in it, and adjust the distance for your phone inside the box, and you'll get an image on the wall. But the only problem is the image will be upside down. Because anytime you use a convergent lens, any image is always be laterally inverted.
yeah,
Yeah. So you gonna have to change the orientation on your phone. But real cool. It's like a low budget projector. I will send out a video on how to do it. I should really try that though. I'll have a projector at home.
yeah.
Well, try to make a get a projector using your phone. It will be more fun. And using a actual projector.
I go try it later.
Yeah, you have a magnifying glass.
Supposed to, yeah.
Okay, nice. It will work real good if you have a circular one. Yeah, I sent a video there. Justin, I feel like you could really enjoy yourself doing that. You might really like to do that.
Yeah. As an artist, and I like to do all kind of fun thing.
And you see, if you do that and you make yourself your own projector, you could draw on your wall. I mean, you could draw on your wall. If your parents allow it, you could draw on your own wall, right? Because you got the image on the wall. You could just trace it, you know?
Yeah.
Mm, right. So let's continue. So let me just write down the observations, right? What we know for sure is a convergent lens. We know that the image is real. Now, Nicholas, for a convex lens, my image is always virtual, and is it ever bigger?
Convex.
If I have a convex lens, right? Convex. My image is always virtual, and is my image ever bigger than the object?
Um, yeah.
No, it's always smaller. It's always smaller, right? But here the thing, for a concave lens, or sorry, for a convex lens, you have like 5 different cases. Or you have like 5 different cases, right? Sometimes the image will be smaller, sometimes the image will be bigger, sometimes it even have an image being formed, right? So we can't assume anything. That is why she changing the position, because depending on where she put it, you will get either a bigger image or a smaller image. You understand?
Yeah.
Right? Justin, soak that in. So and you saw all the different cases, right? Sometimes the image will be like the same size, sometimes it will be bigger, sometimes it will be smaller, you understand?
Yeah.
What is the goal of a projector? Why do we even want to use a projector? Why do you look at it on your phone? Why you want a
To make
projector?
it bigger.
Right. So she moving this lens back and forth so she could get a bigger a bigger image. And let we look at the cases, right? If you want to get a magnified image, where would you have to put your object? Would you have to put it beyond 2F, at 2F, between 2F and F? Where? Where it looking like it magnified? Tell me. Beyond 2F, at 2F, between 2F and F. Tell me.
R2F?
At 2F is the same size. Check that. The image and object is the same size.
Between F and 2F.
Correct. So we know them thing already, right? We know them thing already. So if you want to get a magnified image, you're gonna have to be 2F and F, right? So we know quite a lot here. And well, the image will be inverted. Image is inverted. Right? So guys, we will have to plot a graph, just saying. Just saying. Right? So read this for me here. Justin, you was reading. So read that for me.
Table 2, image distance V and magnification of object M.
Right. So here, I'm not sure what to do, right? You see they're talking about image distance and you see they're talking about magnification, right? What formula is that? Tell me something. What formula is that? What formula have magnification and image distance in it?
This is the image distance of all the object distance.
Come again?
Magnification equals to the image distance of all object distance.
Perfect. See, magnification is equal to the image distance, which is u all over v, right? Justin, you understand that, right?
Yeah.
But that was you what I was talking the whole time.
Papa,
But that was Nicholas.
and that was me, but I might have a little problem here.
What's that?
No graphic bar.
What is that?
Don't have any graphic bar.
Oh, shucks. Pressure in the camp one time.
Yeah, well, I think it was yesterday I went to school. I had maths and the spiral correct with my phone number and a new graph book.
Now in class, now you have to use our graph paper. Hey.
Already had a stuff up, boy.
Hmm. Justin, you have graph paper?
Nah, my graph look finished too.
Lord, what is with these? What is with all them men? Hey, yo, I can't even. First of all, it's online, so I can't even say share all the graph paper. And if it was physical, well, they do have graph paper to share. The Chronicles of Shiva boys, men.
I
I think
blame
that's
The
I
Chronicles,
blame my
yes.
math teacher.
You blame your math teacher.
Yeah, he didn't want that graph with us do.
Hmm. No, that's a good thing. He giving you plenty graphs to do, but
Yeah.
right,
I finished two graph book in Form 4.
that's a lot.
Yeah.
So hey, look at that. They give you a scale. Wow, that's amazing. Normally they don't really give you skills, so we kind of grateful for that. Right. So Justin, they want us to plot a graph of what versus what.
Plot a graph of magnification M against image distance V.
Right. Magnification against image distance v, and they want me to use a scale of 2 centimeter to represent 0.50 on my y-axis. So what going on my y-axis? Is it the magnification or is it the image distance?
Magnification.
Right. So my magnification is my y and my image distance is x. And in maths, if you want to plot a point, what comes first? Is what comma what?
The X over the Y.
X comma y, yes. If I know is that trouble with this, take this down. This is what I just do. When I know start of physics something, whichever one that come first, that was y, and whichever one that comes second, that was x. So I would have just put the x by the one that has a plus on my x-axis and the y, and the one that has a plus on my y-axis, and just put xy. Right, Justin, you understand everything so far?
Yeah.
Okay, cool. So let me begin to plot. So on my y-axis, I have the magnification, and it's telling me to use a scale of 2 is 0.50, right? Right, so every 2 is 0.50. So this could be 0.50. What would this be, Justin? So every 2 centimeters is 0.50. So this is 2 centimeters at 0.5. What would this be over here?
0.10.
Nah. What is 0.50 plus 0.50? Where's a half plus a half?
just be one. That'll be
Right,
one.
that'll be 1.00, right? What would over here be?
1.50.
Right? And just keep calling out. How about over here?
2.00.
Right? Over here will be 2.50. How about over here?
3.00.
How about over here?
Nah, you're trying to catch me.
For sure, yeah. Pick up on it. So, you see, as a man that don't follow the sheeps, you know? You have to find up your own. That's good, that's good. Right? So this is gonna be 3.1.
3.50.
Right.
4.00.
What is it? 4.50?
No, 4.00.
Oh, right. And the next one?
4.50.
Right. They didn't give me a scale for the x-axis, but that real easy. Oh, we had to go up to 80, right? Figure out a scale I should use here. I'll go up to 80 at least.
2 centimeters for 10 units.
All right, let me see if that'll work. 10, 20, 30, 40, 50, 60, 70. Living it on the edge, boy. Ooh, living it on the edge. Me no work. They can't tell you anything. And you use all the graph paper. Yeah, wasting no trees. Right? Yeah, wasting nothing. Yeah, say no more. So my first point, I'm gonna show you how to do this. As somebody who used to have problems in graphs, like when I was in Form 1, this really helped, man. So you're gonna put x value first, so that's 20, comma 0.15. Right? Justin, can you tell me the other point?
30, 0.65.
Right. Yeah. So let me see if you could show me where 20, 0.15 is. But before we do that, hear what? Before we do that, let me just figure out what one of these small blocks is. So let me show you how to figure out that. Altogether, how much small blocks we have here? How much small blocks we have?
10.
We have 10. So let me show you, right? 10 blocks is equal to 0.50. So how much one block will be equal to?
0.50 divided by 10.
Perfect. 0.50 divided by 10.
0.05.
Perfect. Right? So this is 0.05. This could be what?
0.06.
How much one block is equal to again?
Oh, oh shucks. 0.05.
Uh-huh. Uh-huh. That I want to know. Right, Nicholas? What would this other block here be? It's gonna be what?
0.1.
Right. Justin, what this one will be? Right.
0.15.
Yeah, with 0.15. Perfect. So you catch it now, right? You catch it. Let me know if you understand.
Yeah.
And over here, we have 10 small blocks, and we divide it. So 10 blocks is equal to 10. So how much you think one block is?
1.
Yeah, that one real easy. Real, real easy. And we like to see that. So this is just, and you don't have to do this for the whole graph, eh? You just have to do it to a point so you can understand what to do for the rest of the graph. So see if you can show me the first point. My first point is 20, comma 0.15. If you can show me where 20, comma 0.15 is.
Ready?
Perfect. Right? And Nicholas, you got to help me with the other point. Finding students in Shiva boy is very studious, you know. I don't know.
Of course.
Sakalas before you go.
Yeah.
How's Sakal going?
They're good. Nowadays, you're cool and then so
Like football going good or? He's always be cool when football and thing going good.
I see the other day had two footballers coming to school. Like what's that name, boy? Denzel Smith and Isaiah Garcia.
I didn't see that. Shiva
Yeah,
boys
two
and
of them.
something, right?
Yeah, so two of them coming to school the other day, so he was in a good mood.
I see.
Yeah, you on Jersey and thing.
Hey, he must be blush and knowing Sakal. He like them kind of
Yeah, man, I'm on a smile and thing.
oh, he really like them thing. Right? So Nicholas, I see you already played down. Actually, oh wait, eh? Oh no, you didn't put a point there. Oh, you show me where 30, comma 0.65 is.
or making the line thicker.
What is it?
To make the line to annotate thicker.
How to make the lines to annotate?
Uh,
You just put in a dot where 30 comma 0.65 will be.
Right. And so, ready.
Yeah, that look incorrect. Big up yourself. Right? Awesome. So we alternating, right? So Justin, what's your next point?
40 and 1.20.
Right. So moment 40, comma 1.20. Just keep in mind every small block is 0.05, eh? So keep that in mind. 40, comma 1.20.
Could zoom it out. Yeah, that go work.
All this because all I don't have graph paper, you know. Hey. Yeah. Mhm.
I blame my math teacher.
Oh, Lord. Oh, let me see if that's correct. Yep, I can confirm that is correct. All right. It's starting to look like what kind of line? I looking like a line or a curve? I looking like,
Not straight line.
yeah, we like straight lines. We ever seen no curve and thing?
Yeah.
I'm not discriminating against anybody. Yeah, just saying. In physics, in physics, we like straight lines. Nothing, not no funny business in physics. You know,
No, no, no.
straight line easier,
Yeah.
right? Cool. What's the next point?
50 and 1.85.
Yeah. Show me what that is one time. Wait up this 50, comma. Yeah, 51.85. Like all him man, good in plotting graphs. I see. Honestly, any graph when or any trouble. Figure out like point something. Justin, graphs give you trouble.
No, not really. I'm guessing for that one. Me ain't too sure if that one accurate.
Let me see. Right. So uh wait, so let me check it, right? So Nicholas, over here will be 1.55. Over here will be 1.6. Wait, 1.55, 1.60, 1.65, 1.70, 1.75, 1.80, 1.85. I'll be over here. You understand how I do that?
Yeah.
I say I like good in graphs too, really. Say that too easy.
Nah, yeah. You said that too early.
I'm
Jinx
gonna
it.
stay quiet. I'm gonna stay quiet. I'm not jinx anything then. Eh, what's your next points?
60 and 2.35.
Right, you will handle this since you get the last one wrong. Right? 60, comma 2.35. See if you can figure out this one. That's the big circle, just Sandra.
No. Down.
You're so close, huh? Actually, don't tell you. It was so close. That would be 2.30. Wait, right there? That's 2.30.
Oh, so one above.
Yeah. You know how I figure out that? Each small block is 0.05. So they get 0.35 of animals divided by 7. Because 5 by 7 is 35.
Right?
You understand?
Okay, yeah. See what you mean. Right.
So that would be, and I could even demonstrate that. So like 2.05, 2.10, 2.15, 2.20, 2.25, 2.30, and it should be 2.35 right here. And again, we are seeing a funny business straight line. Love it, love it. Right. So you could fix out my sense you get two wrong in a row. I believe you can redeem yourself. I believe you can. No?
One way to find out.
Yeah, one way to find out. And well, Justin, you handle the last question. Or the last point. Right, so after today we finish with lenses. No more lenses. Right? So show me 70, 2.95. Let me see if you can do this the hard way or the easy way. 70, 2.95.
Hmm.
And Justin, you tell him if he correct.
I do now.
Nicholas, you doing this one.
Oh,
Oh,
shucks.
I'll be ready.
Yeah, what's all they get it? Right? The easiest way to do that, 2.95 is 0.05 less of 3. So it's just one block below 3. You understand what I mean?
Yeah, that's what I'm doing.
Nice. But you know, I get an accident yesterday and thing.
Really?
Oh,
Yeah, like I ran off the road completely. It had oil and the rain was falling. Car fly off the road and went down like 1.5 meters down like a decline inside the road.
Hmm.
The car was like down. Yeah,
yay, boy.
yeah. So
He's driving fast, so
I was driving at 40 kilometers an hour.
Hmm.
40. I just feel I lose control of the vehicle. Brakes wasn't working. The the steering wheel wasn't working. I just slide. Yeah.
oh,
You can't tell the car was an accident. You can't tell it was an accident, honestly. It wasn't that bad. But like when I try to pull out the car, they break something.
oh,
Yeah.
under the car.
Yeah.
Yay.
Hmm.
Oh, that good. Other than getting any kind of injuries, like,
Yeah, my girlfriend like normal. She went to work on it today. I I cannot traumatize it. I was real. Hey, that was scary. But 83.52. Right. So Justin, how you handle this last point, right? This last points.
Right.
Justin, I think you gonna manage with this last point?
I will try something.
Yeah, 80, 3.52. 3 point 5 2. 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 3 This one is a trick one.
Oh.
You how to like guesstimate. I just call it guesstimate.
Oh God. Like DNA? Like in the middle of one block?
Yeah, righty. Righty. Mm-hmm. You didn't get a catch. I had a message in mom and tell she is a boss.
Yeah.
Right? And as you all could see that perfectly straight line. Yeah. Look at that. Well, I mean, not perfectly straight, but oh well. It's straight enough. Yeah. So, so you know about best fit something? Or you know about that? Best fits?
No.
Yeah, I know what.
So, Justin, you was the one that say you don't know about best fit?
No.
Okay. So you see how I'm just draw back that line there. So you see, if I put the ruler, do all of the points line up exactly?
Yeah.
Nah. Look at this.
Oh, oh. Yeah.
Watch. How about this? How about this? You understand?
Yeah, yeah.
It's basically if I have some points and the points looking like this, right? What I would do is I would draw a line that's kind of like an estimate of all the points, basically. Our best fit means. So like I wanna have like like a equal distance between points. So I wanna be like I wanna have like a good average, basically. Right? I would draw my line here. Seem like a good place to draw my line. Yeah, that looking like a good place. Yeah. So I want you to observe something, Justin. Did my line pass through all of the points exactly?
No.
No. But what I did make sure was that okay, so you see what I have like a distance between this point and the line? Notice
Yeah.
that it have a similar distance here and here. So it kind of like in the middle.
Yeah.
That's our best fit. Now
Ah.
I saving some time. So I'm not putting in the scale and thing, but you're supposed to put your scale. You have to put your scale, you have to put your title to get the 8 marks. Right? What is my graph here?
Right.
So read this question here from that.
Given that G equals to 1 over F, calculate the focal length of the lenses.
Right. I'll leave out a question here. Yes. I'll leave out a question here. Calculate the gradient G. Right? So we have to find gradients. Does anybody remember the formula for gradients? Alias mathematics. Alias math
Y2 minus Y1 over X2 minus X.
right? That's what we're talking about. Y2 minus Y1 over X2 minus X1. Right, Justin? You know this formula?
Yeah.
And this is the formula you use no matter what the question is. This is the formula for gradient. It's never changed. To find gradient, you need 2 points. Let me take 2 points from the graph. Now you cannot use any of the points they give you. You can't do that. You have to read it off from the graph itself. So let me hear, guys. I want to take 2 points from the graph. Take 2 points from the graph. Nice points. So take 2 points from the graph. Anybody? But it can't be any points I was given.
RCN on the x-axis, 35 on the y-axis 1.
35 and 1. That's perfect. Yeah. Those are good points. Right. Are you seeing any other nice points that I could potentially work with? Okay. Justin, how it's you see any points I could work with?
Um, $55 and 2.02.
55 and 2.02 right here.
Yeah,
And who's that? Nicholas, as you?
Nike, Kabir, Justin.
Oh, okay. I'm tired. Sorry, I'm tired of all the voice. Yeah, I'm tired. Right. So this is it's almost 55 and 55, come on, what? That is 2.1.
2.02.
2.02? Nah. Remind me, how much one of these small block is? Small block.
Or 0.5.
Right? So this is 0.05. So this is 0.05, and then that's another 0.05. So it's 0.05 plus 0.05.
0.1.
Where is it?
0.01. I mean 0.1.
Yeah, that'll be 0.10. Well, that'll be 2.10, sorry. 2.10. So here what it really doesn't matter which one is x1 y1 and which one is x2 y2. It don't matter. You could let anyone be x2 y2 or x1 y1. It don't matter. Which one only want to call x1 y1? Like I say, it don't matter. Yeah, which one only want to call x1 y1? It don't matter.
I could call it.
Wait, sir?
I could call it.
Yeah, which one is x1 y1? Just tell me which one. One or two?
1.
This one over here?
Yeah.
All right. X1 y1, and if all of this is x1 y1, this could be x2 y2, right? So tell me what to write.
So it's 1.00 minus 2.01 over 35 minus 55.
Now let me ask that question, right? Since this is a since is a convergent lens, right? Is a convex lens. My focal G was 1 over F, right? Which is the inverse of the focal length. The point is the focal length for a con for a convex lens is positive. If you remember from the last question, I'm gonna show you the last question we had done. And in the last question to solve it, the focal length had to be negative.
Yeah.
And that was for a divergent lens. But over here, we have a convergent lens. So whatever answer we get, it's supposed to be positive. This supposed to be positive. So let me see. Plug that into the calculator, and let me know what you get.
Minus 54.06.
Minus 54.06.
Yeah.
Let me check that. That seemed oddly big. Again, 11 over 200. Eleven over 200, which works out to be 0.055. That's what again. How you get that? Show me where you plug into the calculator.
Well, I get it correct, you know.
Nice. And Justin, what about you?
Yeah, good.
Oh, for some reason I think that's Nicholas talking. Nicholas, stay there.
Yeah,
Okay, Nicholas, you plug it into the calculator.
11 over 200.
If you plug this into the calculator,
Yeah, I already get you.
okay, nice. Now here what? The gradient, that's a 6-mark question. It seems very simple. Let me tell you how the mark will be awarded. If you write this, you will probably get 5 marks or 4. The final mark comes from the unit of the gradient. Let me show you what I mean. So on the graph, on the y-axis, it was magnification. Now, does magnification have any units? Remind me, guys, does magnification have any units? Nah, magnification don't have any units, right? Because magnification is just a ratio. So on the y-axis, so on the y-axis, I don't have any units. Justin, you understand that? Magnification don't have any units.
Yeah.
However, on the x-axis, I was measuring image distance. What is the unit for image distance? What was the unit for this? What was I measuring the image distance in? Justin, you know what I'm talking about? I'm gonna if you're okay.
Well, I can also be here.
What did I measure the image distance in? I measure it in meters, centimeters, amps. Well, I measure the image
Centimeters.
centimeters, right? So on the y-axis, I didn't have any units. However, on the x-axis, the units was centimeters. So my units will be centimeter to the power minus 1. And that's because when I bring up the centimeters, the power will now become negative, right? Justin, you do what maths?
Nah.
Or what shucks? Well, basically, anytime if I have something in the denominator and I bring it up, I'll write it as x to the power minus 1. Or like if I had 1 over 5, and I bring up the 5, I'll write it as 5 to the power minus 1. So in this question, on the x-axis, you notice on the x-axis, your units were centimeters. So when I take the
Yeah.
centimeters and I bring it up, that'll become centimeter to the power minus 1. So that's where your last 2 marks was. Your last 1 mark or 2 mark, right?
Right.
Cool. This question here now. They say that G is equal to 1 over F. F is the what?
Focus length.
Focus length, right? And what was G? Remind me, what was G?
G is 0.055.
Right, G is 0.055. So look what I'm gonna do, right? I'm gonna say 0, it was 0.055, right?
Yeah.
Now, if I want to find for F, what do you think I ought to do?
Divide by F1 the other side.
Nah,
Or
take, take inspiration from this question. Watch, you wanted
we
to
did do this last class, but I can't remember.
right here too. Check it out. If you have 1 over V and you're trying to find for V, you go flip both sides. So if I'm trying to find for F, I would flip both sides. 0.055 is the same thing as 0.055 over what?
F.
Over what? I could write 5 as 5 over 1, right?
Right. Right.
So 0.055 is the same thing as 0.055 over,
1.
right? And I want to find for F, so I'm gonna flip both sides. So if I flip both sides, what would I end up with?
1 over 0.055 equals to F.
Perfect. And what is 1 over 0.055?
I get 18.18. That's all.
I mean 18.18.
Yeah.
Yeah. Right, so what's the units for the focal length? Or we just measure length and
Centimeters.
yep. That's your 3 marks there. I mean if you understand that.
Yeah, easy 3 marks.
Yeah. Right. And well, we had this last question. We had this last question here. Right. So let we handle this one. That'll be it for lenses. Right. So our way to Nicholas, our way to help me with this question because I hear you. So read this
Here,
question. No.
figure 4 shows a full scale diagram of an object O, which has a height of 3 centimeters. The object is placed 8 centimeters in front of a divergent lens L.
Right. So they say any object is placed 8 centimeters. What is that? The image distance, the object distance, what's that?
That's the object distance.
Right. So over here, what we're gonna put over here then?
That's it will be 8 centimeters away from L.
Right. So 1, 2, 3, 4, 5, 6, 7. So this gonna be 1. Two. Right. So read parts 1 from
Given that the focal length of the lens is 5 centimeters, draw the ray diagram in figure 4 to find the image of the object.
right. Let me show you how we're gonna handle that. So stay with me. You're gonna be okay. We've done questions like this before. Right. So where's my focal length? Where did they say the focal length is?
5 cm.
Right. So where would that be?
That would be on 5 centimeters.
Right. Right here. Your first rule. Do you remember the first rule when drawing? Basically what we do over here is basically what we do just now. What's my first rule?
Um, this rule was, I think I remember.
So anytime you want to draw a ray diagram, we're dealing with a divergent lens here. So you're going to draw. Tell me if it's correct. Could I draw a line like that? Tell me if that's correct.
I can't draw a line there.
Where the line had to be coming from? Coming from over
Yeah,
here, over here,
had to be
over here,
from the top of the 2 centimeters.
right here, right? Cool. And it's a divergent lens. So when the light ray hit the lens, it had to diverge, right?
Yeah,
Is this correct?
it had to be on the focal.
Perfect. It had to pass through that 5, right? Had to pass through the focal points. Let me know how that looking.
Yeah, that looking correct.
Cool. So a light ray, it coming in, right? And it diverge. So it will look like it coming from the focal point. So the first rule is that if you have a light ray parallel to the principal axis, when it passes through the lens, it will appear as if it's coming from the focal point. That's the rule. So you see this over here, that's a light ray. The light ray is parallel to the what? What's the sign over here?
That's the principal axis.
Yeah. And it will diverge, but since it's diverging, it will look like it coming from the focal point. You understand?
Yeah.
Cool. That's one rule. What's the other rule?
The other rule, and it had to intersect.
No, you had to use the other rule to get the intersect.
Alright. I think it is something.
So let me get a chance to copy down the rule there. The rules there. Um so then was the two rules you had to know.
Yeah, I get it.
Right. So which rule we just now apply? Was it rule 1 or rule 2?
Just do
What is it?
now do rule 1.
Rule 1. Right? The next rule we're gonna do, we have to draw a line, a light ray that passing through what? Can I draw it like this?
Now it had to pass through the optical center.
Had to pass through the optical center here, right?
Yeah.
Right. And since it passed through the optical center, I going straight through. Nothing happening. Nothing happening. You understand?
Yeah.
And drawing the arrows is part of the marks. So you have to draw the arrows to indicate the direction of the light ray. Where are you seeing a point of intersection?
Right. Yeah.
Yes. Now I could draw my diagram a little better. I'm gonna see what I could do. I'll wait till I go through exactly. Wait. Mm. Right. So my image is being formed right here. Let me know if you understand that.
Yeah, I understand.
So since it was a divergent lens, tell me the properties about the image.
Alright, so the image is virtual. It
Right.
is upright and
It's smaller
um
or bigger?
smaller.
Smaller. And if you want to say that fancy, you say diminished. Yeah. So you know all the terms and thing now, right? So we don't really have to do any calculations for this question. They want me to read off the graph. So Nicholas, this thing over here was 3 centimeters, right? This was 3. So what do you think one of the blocks is,
1,
right? So then what do you think one of these small blocks is?
0 point, hold on, 0.2,
0,
0.00,
0.02? Nah, it wouldn't be
0.2,
0.02. Be 0.2,
yeah,
right? So then this over here, if I wanted to figure out my what would I call this over here? That's my what?
that is the image height,
Perfect. That's the image height. So my image height is what my image height looking like?
1.2,
1.2. And my units gonna be centimeters, meters, with this.
yes, centimeters.
Right. Justin, I wonder if you understand that for sure, for sure.
Yeah.
Nice. So the image distance, well, they want me to find the image distance, right? Justin, so I'm always the image distance. How far is my image from the optical center?
1.2 centimeters.
Now, what I 1.2 is the image height. That's the image height.
Oh. Okay. So 3.2 centimeters away.
Yeah. And this last question is kick. Was the image real or virtual?
The image virtual,
Right. Right. So that's the inner lenses. I'm gonna follow you cool with everything. All right.
yeah, we good there.
Nice. So guys, thanks for coming to class today, even though it was a bit late. So I will see you all there when I see you all there again, buddy. Well, when I send you schedule, I'll just send you schedule for next month. Yeah.
Yeah,
But have a good one, guys. Later.
yeah, same to you.
Yeah.